Well, this is what I've been playing with all the last to keep myself busy for a while. So this is a little knock-up of a GPS disciplined oscillator. So I've got a crystal down there, oven crystal, connected to a Raspberry Pi Pico, which is using a novel technique for the to count the pulses. Bit of a GPS unit and some sort of random synth there, feeding out to a frequency counter. And the I just did it because it was something interesting to do. So the Pico has programmable I/O. Sort of, you could think of it as almost a small FPGA on it, on the inputs, so you can get stuff done without having to bother the processor. And I'm using it to count the 10 meg pulses, and then every time the 1 second, 1 pulse per second of the GPS fires, it transfers the current count to the processor, where it can do some hard sums and a bit of averaging and a bit of PID loop and all the usual stuff, and discipline the very slowly discipline the oscillator to stay roughly on 10 megs. Well, very quite close to 10 megs over roughly. It averages the readings over a minute and steers it to where it needs to be, and yeah, that works quite well. The little SV1AFN synth there just locked up to produce whatever frequency it needs. And right, I'll just the plan with this is to produce a PCB with two synthesizers on it, so I can get 2 fully independent outputs. And I'll just let's have a look at the software. The software for it, something I just wrote in Python so you can set the thing up if you need to, and you can also just monitor what it's doing if that sort of thing cheers you up. So you can see if it's got a little display that mimic the LEDs that are on the which will be on the final PC board. There's a GPS fix, GPS lock. It shows you whether the PLL itself is locked, whether the oscillator has managed to get into a disciplined state, which basically means similar to phase lock, but a little bit bit looser. And you can set 2 frequencies up for the outputs. There's various other pages that show you the debug information, if you like. There's a tuning page that lets you set up the actual values used in the correction loop. That's sort of interesting. It basically locks to faster rate and then divides the rate down by opens up the averaging window by a factor of 4 and divides the control down by a factor of 4 once it's locked. So it's got a bit less grip on it. It keeps it a bit more stable, which is what's needed in our application. You can save and restore settings to a file, and there's usual stuff. All this stuff's on GitHub if anybody ever wants to look through it or download their own copy or whatever. And setting a new frequency is very simple. You just put in the value you want, and off it goes. Writes them to the EEPROM on the device, and once the device is programmed, you can disconnect the USB. It's only needed for configuration. It's not needed for anything else. It'll run quite happily on its own. And yeah, it's an interesting thing. A lot of the other GPS disciplined oscillators use a traditional phase lock loop and long time constants, and this one does it through pulse counting on the on a Pi Pico, using the sort of the offboard hardware, onboard hardware front end that's available on the Pico to set up some counters, and that way no pulses are missed, and it's not dependent on interrupt requests really for its accuracy. It's still going to count without missing any pulses, regardless of really what the interrupts are doing. As long as the interrupt can service it once every second, it's fine. So anyway, that's what's kept me going with that. And what got me into this rabbit hole was, of course, work on the 5.7 gigahertz project, which I'll come on to next. So yes, the 5.7 gigahertz transverter. This is something that was bought from a sadly departed silent key sale of a local friend, and very nice it is too. I've added a load of bits to it. Just need to make the mounting a bit more secure. Basically, we've got a 48 volt, 12 volt converter that drives a 12 volts for this section. There's a DB6NT transverter in here that does 144 to 5.77, and this is an Anglian doing 28 megs to 144. So for example, the transmit path comes in here at 28 megs through the Anglian, out of the Anglian into this transverter, out at 5.7 through here into there's a nestling in the bottom underneath all that is a 20 watt power amplifier. That comes out at 20 watts of 5.7 into this into the output relay, and again on receive it comes through a nice Kuna LNA in through a bandpass filter down here into the transverter, and then again through the 144 to 28 and out at 28 megs down the cable. And there's all the usual control cable interface, so you can control it remotely. And the plan is to add to this. I've got one more thing to add to this, which is an output to drive my big waveguide relay and the travelling wave tube, which could be added to it to give us a bit more power when needed. But yeah, that box is coming along. Of course, the box has to mount on a tripod, so let's go and have a look at that. Right, so excuse the mess. This is the tripod, and that is the relay which we spoke about. Right, so this is the tripod that we use with the 5.7 gigahertz system. The plan is that the TWT will mount on the back here, drive into this input port. I think I had the dish slots on the front there. That's all done and tested. That's all waiting to go. And the bit I've been working on is this dirty great big cog. And the idea of the cog is I've got a stepper motor and yet more software, obviously, that will mount on a plate somewhere under here and allow me to rotate the thing while sat comfortably in the car. That's the plan. Lovely little planetary gearbox on that. And yeah, the plan is to be able to sit in the car, pan this thing around. All the remotes for that box are brought back down a cable, and 28 megs for the RF, and a honking great big relay, which we'll use if we put the TWT on it. The TWT is sat over here. That's the TWT, which is pretty much brand new. It's got about 100 hours use on it, and that's a 400 watt travelling wave tube. So yeah, that should be quite fun. But yeah, if we can get that mounted on the back, I've already got the 4-foot dish to go on this. Everything will be good. Those of you that use my KST chat software for random microwave nonsense, I've got a new version. I thought I would. It gave me something to do for a day or two. Works very similar to the old version. Will run on any laptop or tablet. It's just a web page. There's no software to download. Connects over WebSockets to the KST server. Same as before. User list or chat list of users. The ever popular map. You still get your path profiles, etc. But amusingly, we now have a couple of other options. You can chat in the usual way. You can actually spot an individual user rather than we used to be able to only spot beacons. You can actually spot a user now, which is quite useful. And I've added an aircraft scatter thing to it because I don't know, it seemed like a good idea. So, oh, in fact, there is one. So on the path between G4 SWX and myself at the moment, there's this aircraft here, the blue one. This one here, which is at 26,500 feet coming in. We've got 2 minutes of contact time left. It's an elevation of about 3 degrees from both of us. So, yeah, that works. And it also shows the planes that are coming in, that will come in. Whether the heavies get more stars, higher altitude gets more stars, etc. It relies on them both being in sight and a bit of takes into account the diffraction index, etc. of the atmosphere. So yeah, so that's that was something to do. It doesn't need any. It uses a free plane feed from ADS-B1. It takes I think it takes a new feed every 10 seconds and just relies on dead reckoning in between those times. And yeah, so that seems okay. You can just click on any station really. It'll see if there's no planes that have been high enough for that. No, that one would have worked. That had got a plane high enough. But yeah, it's maybe people will use it. Maybe it's useful. Don't know. If not, just stick to the normal map. If aircraft scatter isn't for you. What else have I added to this? I'm sure I've done something else. Oh yes, if you've got chats waiting. I don't have any. You get very much like you can see people who've left, tried to message you and you haven't been able to respond yet. Very similar to Facebook messaging. You might like that. If not, you just ignore it. But yes, that gives if people are calling you and you can't keep up with all the different conversations, which is often the case with KST, this should help sort it out. They'll appear just as in a list, just like they would on Facebook waiting messages, etc. And just because I've related to the 5 gigahertz project, I wanted, as I said, I've put that big cog on there so I can rotate it remotely, and I wanted a way to rotate it. So I've written some rotator software. There you are, rotator software. Again, running on a little Pi Pico. It knows where you are. You set your location, and it knows where you are. It knows where they are, and you can simply get it to. Oh, I haven't set my location. There you are. Silly me. Set my current position. Set my location. Sorry. Set my current location as to be IO82UJ. There we are. And then it knows angles for all the different people you've got in and their locators, and it can just. I'm not actually connected, but it would just point at them. You can pan it left and right. You can use your mouse to rotate the thing just off the mouse wheel. It knows where it's going. It knows where it's got to get to, and it chats over serial to the rotator head itself, which will be on my dish or whatever. Yes, that's the rotator software, and it's linked to if KST spots there's one connected. It links gives you rotate button, which will add or it'll add them to the list and automatically pan up upon them. So simply by pressing rotate in your KST chat, you can get to the rotator to pan round to them, which is again, it amused me at the time. I can see I've still got a plane that's going through the path. Oh yes, look, 2 planes on that path. So yeah. Anyway, that's what I've been up to. Don't know if it's of any use to anyone. It certainly kept me amused for a few days in the week. So all the links will be in the doodly doo, as they say. And if it's hopefully some of those are of some use to people. Anyway, I hope that was interesting. That's shows you what I've been wasting my time on. Right, okay. Thanks for that. See you again.